Design of final product testing in the forging industry. Problem definition.
There is scope to apply image processing techniques for quality control of industrial product. The image processing techniques are very powerful tool for automatic, fast and easier defect detection and quality control of various types of products. Algorithm is proposed for real-time quality monitoring of manufactured product. This proposed system can replace manual inspection of industrial product. Result will indicate product is defective or non-defective. Using this automatic inspection system, cost of inspection will be reduced, also accuracy of inspection will increase. This proposed idea can be enhanced with some advanced and extra features. We can use a conveyor belt for capturing images of products that come directly out of the product line. After getting result from system, we can separate faulty products and good products. We can also maintain count of good products as well as faulty products produced in the entire day. A daily analysis report can be generated which can be viewed by the manager as soon as the task finishes. Major problems we try to solve are: image processing system using cameras and image processing techniques to identify undesirable objects on roller conveyor lines. The cameras above the conveyor capture images of the passing objects. The roller background information is removed and images of the objects remain. To analyze each individual object accurately, the adjacent objects are isolated and small noisy residue fragments are removed. A spherical optical transform and a defect preservation transform preserve any defect levels on objects even below the roller background and compensate for the non-Lambertian gradient reflectance on spherical objects at their curvatures and dimensions. Defect segments are then extracted from the resulting transformed images. The size, level, and pattern of the defect segments indicate the degree of defects in the object. The extracted features are fed into a recognition process and a decision-making system for grade rejection decisions. The locations in coordinates of the defects generated by a defect allocation function are combined with defect rejection decisions and user parameters to signal appropriate mechanical actions, such as to separate objects with defects from those that are defect-free. Majorly we need 4 components: controller, that is, Raspberry Pi, camera module, conveyors belt, and monitoring display.
Now, working explanation. 1. Quality verification using image processing. Digital image processing techniques are employed to verify almost all the products that are coming out of the product line. This is pursued by taking image of each and every product as soon as it comes under the camera. Captured image is fed to the computer for further processing. The colored image is converted to black and white image and then to binary form. This binary image is then subjected to template matching. This proposed idea of using digital image processing helps to save time, as the process to carry out quality testing becomes fully automated and results in increased productivity. It gives accurate results as industries carry out manufacturing on large scale. It also reduces human efforts. 2. Image conversion. The captured image is an RGB image which needs to be converted into binary form. A grayscale digital image is an image in which the value of each pixel is a single sample, that is, it carries only intensity information. Images of this sort, also known as black and white, are composed exclusively of shades of gray, varying from black at the weakest intensity to white at the strongest. 3. Template matching. Template matching is a technique in digital image processing for finding small parts of an image which match a template image. It can be used in manufacturing as a part of quality control. The binary image is given as an input for template matching process. This image is compared pixel by pixel with the template image of an ideal product to verify the actual shape and dimension. Matches are estimated based on the intensity values of both image and template. If the templates match accurately, then product will be considered as a non-faulty piece. 4. Edge detection. Edge detection is one of the most commonly used operations in image processing and pattern recognition. The reason for this is that edges form the outline of an object. An edge is the boundary between an object and the background, and indicates the boundary between overlapping objects. This means that if the edges in an image can be identified accurately, all of the objects can be located and basic properties such as area, perimeter, and shape can be measured. Since computer vision involves the identification and classification of objects in an image, edge detection is an essential tool. Efficient and accurate edge detection will lead to increase the performance of subsequent image processing techniques, including image segmentation, object-based image coding, and image retrieval. A color image edge detection algorithm is proposed in this paper. Average maximum color difference value is used to predict the optimum threshold value for a color image, and thinning technique is applied to extract proper edges. The proposed method is applied over large database of color images, both synthetic and real-life images, and performance of the algorithm is evident from the results and is comparable with other edge detection algorithms. Flow diagram of the system. Proposed architecture of system indicating sequence of operations to detect defect. Image will be extracted from VIDI using OpenCV. High-pass and low-pass filters will be applied on image to enhance quality of image. High-pass filters will highlight regions with high frequencies. Low-pass filters used for image smoothing and noise reduction. Their effect is averaging of the existing pixel with the values of its neighbors apparent as a blurring of the output image, will allow to pass the low frequencies.
The Raspberry Pi is a low-cost, credit card-sized computer that plugs into a computer monitor or TV, and uses a standard keyboard and mouse. It is a capable little device that enables people of all ages to explore computing, and to learn how to program in languages like Scratch and Python. The Pi camera module is a portable lightweight camera that supports Raspberry Pi. It communicates with Pi using the MIPI camera serial interface protocol. It is normally used in image processing, machine learning, or in surveillance projects. A modular camera is simply a camera built up of individual smaller parts that can be configured in multiple ways. Modular cameras allow for interchangeability of camera components and accessories. Belt conveyors are used in self-unloading bulk freighters and in live bottom trucks. Belt conveyor technology is also used in conveyor transport such as moving sidewalks or escalators, as well as on many manufacturing assemblies lines. Stores often have conveyor belts at the checkout counter to move shopping items. Conveyor systems, often called conveyor belts, work by using two pulleys that continually loop over the material that rotates over them. The belt is then supported by a series of rollers along the path. The rollers in the center of the device prevents the conveyor from sagging in the middle while it is carrying a load. The keyboard is a gorgeous web interface that displays photographs, weather, and other information, such as events from your calendar or Wunderlist to-do list. Hooking up a Raspberry Pi to a monitor is one of the easiest things to do.